Okay, so the 33rd problem in the lead code is to search in the rotated sorted array. Okay, so before actually jumping on to this example, let's try to understand what is being given here. Okay, so this is the given list, sorted array. This is already sorted, and actually before actually the problem is about to search in the rotated sorted array, right? So actually before actually giving us this array, so what they are doing is, so there was a sorted array. So before actually giving us that, they are rotating it by some k times, okay, n number of times. Okay, so what is that n here? N is 3 here. Okay, so how does it look after rotating, right? So this is the array. If you rotate it by 3 times, it will look like this, correct? So 0 would go to the end, 1 would go to the end, and 2 would go to the end. So at the end it will be looking like this. This is the rotated sorted array. Okay, so after rotating we got this, like, I mean, after rotating they will pass that array to the our function, okay, search function, and will be given as a target. Actually, like, we need to check if this value exists in the rotated sorted array or not. Okay, if it exists, we'll have to return the index of it. If it doesn't exist, we'll have to return a -1. Okay, so now we could actually just use the loop, and we can iterate through and find out if the element exists or not, right? If it exists, we can just return for index, or we can just return -1. But the thing is, we do have a restriction that we'll have to solve this in log n complexity. Okay, time complexity. We cannot use the for loops to identify the element, like, I mean, if it exists or not. Okay, that is one thing. And also secondly, right, like, as we know, if it was just a sorted array, right, we could just go for a binary search, correct? So actually, let me just try to give an overview how that binary search works here, right? So if it was a sorted here, what we could have done is, this is a left pointer, and this will be our right pointer. And like, what we could do is, we could just find the middle element, right? We'll find a middle element. As we know, it is a sorted, we'll go to middle element, and then we'll try to find out if the element exists here or here, right? And maybe if you are trying to find out a 6, right? So 6, like, we'll try to, after finding out the mid element, we'll see, like, if the mid element itself is a 6 or not, right? It is not. So then we'll see that 6 is greater than 4, or, like, I mean, 6 is less than 4. Like, on basis of that, we'll try to find out, we'll jump to this part. And similarly, it will go on, correct? Like, I mean, this is how it works, right? Left pointer, right pointer, we'll be updating our left pointer here when we want to go to the second range, all these things, right? But this binary search would work only on the sorted arrays. It won't work on a unsorted one, correct? So as soon as we rotated it, we made it as an unsorted array now, correct? Just by looking at it, it is 4567012. This has become unsorted array, but so that we cannot use a binary search here, correct? So we'll have to, but what we can do instead is, we'll modify the binary search approach such that that can be used here. Okay, so how we are going to do it? Okay, so how we are going to do it is, so let's start with the binary approach thing only. Okay, so we'll set our pointer to the left here, and we'll set our right pointer here. Okay, and then what we'll do is, we'll try out the middle element. The middle element is this. Okay, and our target is 0, right? According to that example one, we'll have to find out the 0. We'll see if the mid element is equal to 0. It's not, correct? So now we have this kind of partition. Okay, we have one two sub arrays, basically sub ranges for a list. Okay, so now we need to identify which is sorted, correct? Now I don't know, like, just by looking at it, right? If the I can say this is here, but I want to find out if 0 is exists in the left side or in the right side, correct? So how can I identify, right? Let's say that if it was a sorted already, let's say that I want to identify 6 exists either here or here, correct? So I cannot, if on a unsorted array, I cannot go and apply any condition to get check if this element falls into that or not, correct? If it is a sorted one, I can easily say that if 5 is greater than 4 and 5 is less than 7, x is less 4, right? 5 is greater than 4, 5 is less than 7. So that I know that this will be obviously falling in the first range, correct? So that I can go here and search for an element. So the first step is, what we are doing is, we'll be setting our pointers, left pointer, right pointer, and we'll be setting the middle one. And the next thing is, we'll have to identify which part is sorted, or sorted here, right? To identify. Okay, let's go to the next thing. Okay, so how we are going to identify, right? Let's say that if the whatever the left element, if it is lesser than the right one, it means that this is already sorted, right? Initially this was a sorted array, it was just rotated by some means, right? So that's why all the elements are already arranged in an incremental order. So it means that it's in a sorted one. Okay, so now we got to know that this is sorted, correct? So okay, now once we got to know that it is sorted, the second thing is we'll have to identify if the target falls under this or not. Okay, so let's say that 0 we are looking for, right? We'll see if 0 is greater than 4 and 0 is less than 7, not right. So we just identify that 0, it doesn't fall under this category. 0 would be belonging to the other part of the array. Okay, so now what we'll have to do, we'll have to apply the same logic again with this part. So how we are going to do it, our left pointer was there, right? So we'll be moving to this, right? Our left pointer will come here and our right pointer will stay as it is. Okay, so now again the same thing. Okay, so what we'll do, we'll try to find out the middle element. uh, we'll try to find out a middle element, and then we'll see like if the middle element itself is the target if we are looking for, right? 1 is equal to 0, is this the element we are looking for? No. Okay, this is our middle element now. Okay, so no, now with next thing is we'll have to find out a sorted array. Okay, but here this is just a one element, so but still the algorithm still have to be remain same, right? So we'll try to find out which is sorted. We'll say that 0 is less than, like, I mean, let's say that we'll check the left element is less than or equal to the mid element, right? If that is the case, we know that this is sorted array. Okay, this is sorted array and the other one is unsorted, but here it is, this is also sorted. That shouldn't be a problem. Let's assume that this is a okay, so we know that this is a sorted and this is a sorted and this is also sorted. But okay, so now what we'll have to do is, once we got to know the array is sorted, right? So we'll check if that element falls under this or not. Okay, so what we'll do is we are trying to find out a 0, right? If 0 falls under this or not, 0 is greater than or equal to the left element, which is 0, right? Obviously now we know that this falls under this one, correct? We fall under here, correct? So what we'll do is, next thing is we'll do our iteration. Basically, like, I mean, our right pointer will be pointing to this, right? We'll have to point to the somewhere like before the left mid one. So at the end what will happen is left will be pointing to the same thing, right? Like we will in this way, like, I mean, like, I mean, this will be pointing to this, right? And whenever if we try to find out a mid element for this, obviously we'll be landing into the same. So that's how we can identify the target if it exists here. If it doesn't exist, we'll be exiting the loop. Like, I mean, we'll be incrementing our left pointer, that condition will be breaking, and we'll have to return the -1 at the end. Okay, so now let's quickly look at the code. Okay, so to check here, right, this the code. Yeah, so the first thing what we'll do is we'll initialize our pointers. Okay, left pointer and right pointer. Left is 0, right is to the end, and then we'll try to find out a mid element. Okay, if mid element if itself is a target, then we'll just return the mid. Okay, the mid index. Okay, and next thing is the next step is we'll have to identify the which part of the array is sorted. It is reversed now. We'll have to find out if the first half is sorted or if the second half is sorted. Okay, once this condition is to check if the first half is sorted or not. Okay, once we know that this is sorted, okay, now we know which part is sorted. Either this is the first half is sorted or the second half is sorted. Okay, so now let's assume that the first half is sorted. Okay, if the first half is sorted, then check if the element falls in the sorted array itself. Okay, this is the condition to check if the target, whatever the target, right, if it is greater than nums of left and if it is less than nums of mid, right? If it is falling into that, it means that we are in the left sorted array. Okay, and also target also falls under the left sorted array. Okay, so in that case, what we'll have to do, we'll have to change our right pointer to the less than the mid one. Okay, we'll have to left shift by one time for the mid one. Okay, that's why we got it. Okay, and let's say that we are in the left part, right? We are in the left sorted array. Okay, but the target doesn't fall under that left sorted array. In that case, what we'll have to do, we'll have to look for that element in the right part, right? We'll have to, if we don't find that element here, we'll have to look that element here. So that's why we'll be incrementing our left pointer. Okay, and at the end, similarly, if this part said that told that, like, I mean, if this is not sorted, right, left part is not sorted, it means that right part is sorted at least, correct? So once we got to know that right part is sorted, we'll check if the target exists in this right side or not, if it is greater than mid and less than right, right? So if it exists, so it means that we'll need to look for that further for that element in the right side of the element, right, right side of the array. So we'll be incrementing our left. That's it. We'll be keep on doing it until we exactly meet that mid element, right? If we exactly meet the target element as a mid, we'll be returning it. If we couldn't find it, this condition will fail at some point in time, and then we'll be finally returning the -1. That's it. Thank you.